we're going to be learning how to apply order of operations to fractions. It's really important to recognize that yes, we're using fractions. Yes, we may not feel that confident with fractions, but this part, we're actually not learning anything new. We know now the tools and strategies for fractions, multiplication, division, addition, subtraction, exponents. We also know order of operations. Now we're putting those together, right? So nothing is new. We're just combining two things that we've already learned about. So a quick GEMDAS review. I talk about GEMDAS, not PEMDAS, for a critical reason. So I'm going to write out our GEMDAS. I also say always write GEMDAS down because it's your map, right? Rules of the road. When you think about a map, if you're going somewhere that maybe you've been there before, maybe you haven't, you don't drive there and then turn on Google Maps, right? You turn Google Maps on, or if you were me and I had to use a paper map, I would take a look at the paper map. Now, clearly I use Google, but once again, don't want to admit my age, but that sort of does, given that Google Maps did not exist when I started driving. But that's beside the point. You want to look at your map before you go. So that's what we want to do here with GEMDAS. We look at our map and then we look at the problem and we figure out whether where we are in the map applies to the expression that we're looking at. Okay, so GEMDAS, again, quick review. G is for grouping. Now I use grouping instead of parentheses because grouping includes parentheses, absolute value, brackets, and then there's one I can never remember the name of. Now on this video, we will only potentially encounter parentheses and absolute value. The other ones will come later, okay? But G includes all of those, not just parentheses. Then we have our exponents. Then we have our multiplication and division and addition and subtraction. So why do I have multiplication and division and addition and subtraction written horizontally? It's very purposeful. As soon as you have an expression that only has multiplication and division, you go left to right. If you have an expression with just addition and subtraction, you go left to right. So these two things can be, and I think often are, the most frequently forgotten thing. So writing it horizontally is a reminder that direction is what you pay attention to when it's just, and I'll say the same level of operation, right? Like multiplication and division are opposite of each other. Addition and subtraction are opposite each other. So they're the same family, right? Same level. And so again, when you just have the multiplication division, go left to right. When you just have addition and subtraction, you go left to right. Okay, so looking at my GEMDAS, I'm going to rewrite it here. Ooh, I'll use bright orange. That ought to help remind me to pay attention to it. I hope at least. Okay, so remember I said look at your map first. So I'm looking at order of operations and I say grouping. That's what I have to do first. Now I go over to A. Is there grouping? No, I don't see parentheses, absolute value, brackets, or the one that I forget the name of, right? So I'm going to put a little check saying that I checked it. It's not there. Exponents, do I see exponents? In A, I do not. So that means, right, so I checked that one, there's nothing. Now I move to multiplication and division. Is there multiplication and division? Yes, right here. So that is what I have to do first. I'm going to rewrite the 2/5, because that's untouched, plus, now I do the multiplication of fractions. Step 1 is to check for cross-canceling. Well, there's nothing I can cancel, right? So now I move to multiplying across. So I get 5 over 18. Okay, I'm now done with my multiplication and division. So by looking at my map and then going to the expression, I broke potential patterns that my brain would see. A lot of people would have looked at the 2/5 plus 1/3 and done that first, because we usually do. Well, we always read from left to right, but in this case, we don't, right? We're following order of operations. Okay, so I am done with multiplication and division. Now I move to addition and subtraction. Well, what's the first thing I have to do for adding and subtracting fractions? Common denominator. To find the common denominator, I pull out my biggest denominator first. Hopefully this is sounding familiar, right? We're just revisiting strategies that we've learned before. Okay, so 18 is my biggest denominator. So 18. Now, I need to find a number that 5 goes into. So I know that as soon as I have a number that either ends in 0 or 5, that one is going to work for my smaller denominator. I'm still going to start at 1 and work my way up, because, as I've noted before, anytime I skip a number, there's a high probability that that's the one I'm going to need. It just seems to work out that way. All right, so 18 times 1 is 18. 18 times 2 is 36. Now, neither of those end in 5 or 0, so I know that that is not a lowest common denominator that I need. Okay, so I did 18 times 2. Now I have 18 times 3, which gives me 54. That also doesn't end in a 0 or a 5, so I know that that one doesn't work. Okay, now I have 18 times 4, which gives me 72. Again, does not end in 5 or 0. And so now I have 18 times 5, which is 90. That does end in a 0, so I know that 5 will go into that. All right, so my common denominator, my LCD, is 90. All right, I know that 18 times, 1, 2, 3, 4, 5. So 18 times 5 gives me 90, right? What if I didn't know how many times 5 went into 90, or 5 times what gave me 90? You can take the number you're going to, the 90, and I'm going to divide that by 5, and it gives me what I need to multiply by. So 90 divided by 5 gives me 18. So I go ahead and show, right? 18 times 5, whatever I do to the bottom, I have to do to the top. And now I'm ready to figure out what each of my new fractions are with the common denominator. All right, so 18 times 2 is 36 over 90. Now I have a pie cut into 90 pieces. I have a second pie that is cut into 90 pieces. 18 times 5 is 90. 5 times 5 is 25. Draw my arrow, draw my line, place my 90. So notice context is different, but I still have exactly the same strategy, right, as I've done before with adding and subtracting these things. And now I go ahead and just add my numerator, and I get 61 over 90. I'm going to do my quick check. I don't see a common factor, but this is a good example where if you weren't sure, you could start with the number that you're more comfortable with. So let's say 90, right? Well, 3 goes into 90 because 3 goes into 9. So is 61 divisible by 3? No, it's not, right? 9 goes in. Does 9 go into 61? No, 2 goes in, right? So you can check using that number that you are more familiar with to confirm whether there's a common factor. You can also use prime factors, right? Where you use your factor tree. Let's see, so let's do just as an example, right? So 90, this is just a reminder for figuring out prime factors. 3 times 3 and then 2 times 5. So I can rewrite my denominator. 3 times 3 times 2 times 5 using my prime factors. And then 61, I only care if 3, 2, or 5 go into 61. Well, 5 doesn't because it doesn't end in a 5 or a 0. 2 doesn't because it doesn't end in an even number. And then 3, I already checked, but let's do it again. 61 divided by 3 is not a whole number. So I now officially know that I cannot reduce that any further. So 61 over 90 is my final answer. So I love prime factors for determining whether a fraction is fully reduced or not. Okay, so let's go to B. Okay, so we're doing order of operations again, because we always do that. So I'm going to erase my marks here because I want it clean when I go back and use it as a map. So here I have G for grouping. If I look at B, I don't see any grouping. So I'm going to cross that off or check it off. E for exponents. I don't have exponents. So I'm going to cross that off. Multiplication and division. I don't have multiplication and division, so I cross that off. Notice I do have addition and subtraction, and that's all I have. So now it matters that it's set horizontally. What do I have to do when I have an expression with just addition and subtraction? I go left to right. So visually, by crossing off everything prior to the addition and subtraction, it helps me see that that is in fact the only thing I have. So I start with 3/7 minus 1/2. You could do 2 at a time, or you could do 3 at a time and try to find a number that all of them go into. I think because that's new, I'll go ahead and show that you can use the same strategy we did with just 2 fractions to find our common denominator. It's just that we still start with our biggest denominator and then we have to check 2 other denominators instead of 1. All right, so I have 7. That's where I'm starting. 7 times 1 is 7. 7 times 2 is 14. Well, 2 goes into 14, but 4 does not, so that's not going to work. 7 times 3 is 21. Well, 2 and 4 don't go into 21. 7 times 4 is 28. 2 and 4 go into 28. So I know that that is my common denominator. It's nice to do it that way if you're comfortable because you already know you have the common denominator that you need. But you could just do 7 and 2. Once you have that one combined, then you figure out common denominator between that combined fraction and the 3/4. Either way is absolutely fine. Sometimes I find that one way is easier than the other, but that just comes with time. as to choosing. So I would select one method that you like right now, either do 2 at a time or go ahead and do what I did and find a common one for all of them. All right, just for space, I'm going to go ahead and rewrite this so it's easier for me to show what I'm doing. Minus 1/2 plus 3/4. I know that my new denominator is 28. So it's what do I do to each of these denominators to get a denominator of 28? So 7 times 4 gives me 28, right? What I do to the bottom, I have to do to the top. And then I have 28, so 2 times 14 is 28, top and bottom by 14. 4 times 7 is 28, so top and bottom by 7. Now I'm going to go ahead and combine, so I get 12 over 28 minus 14 over 28 plus 21 over 28. Okay, so found my common denominators, which is always the first step when you're adding and subtracting fractions. Now I follow order of operations to get these combined. So I'm going to still do my line and 28, but I'm going to need a second one because I'm just combining the first two, and then the second one is going along for the ride the first time we do this. Okay, so I have the denominator of 28. I do 12 minus 14, which is -2. Don't reduce, right? You may see, oh, -2 over 28. I can reduce that. That doesn't help you though, because you have to have a common denominator. So reduce only at the very end. Even if you come across a fraction that can be reduced, you don't want to until the very end. All right. And again, I'm doing left to right. So I did the subtraction first and got the -2 over 28. Now I'm adding the 21 over 28. So I'm going to do my arrow, draw my line, write 28. Okay, and then I go ahead and do my -2 plus 21, and that gives me positive 19. Well, 19 happens to be prime, so 1 and 19 go into 19. Is 28 divisible by 19? It's not, so I know that this is my final answer. Okay, so go ahead. Oh, actually, I'll go ahead and do C. And then before we move to 2, I'm going to encourage you to pause the video, try A, okay? Watch A, and then go to B, try B, and so forth. We haven't seen parentheses with fractions, but we have seen them and used our order of operations. So it's a good way to check and see your understanding of that combination of fraction rules and order of operations. So it's great at some point to start testing what you're understanding and what you need to go back and review. All right, so for C, once again, you should get sick of rewriting GEMDAS because you should be doing it every time you have a math problem because, again, rules of the road, you always have to use them. All right, so looking at C, I do not have grouping, so I'm done with that. I also don't have an exponent, so I'm done with that. But I do have, in this case, division. Now that's right in the middle. I have to do that first, and I'm dividing these two things. Okay, so again, using GEMDAS as your map helps you identify what you need to do, you find it, and then you just hone in on that part and ignore everything else. Okay, use your map. Use your map. Look at it first, then look at your expression. All right, just because I don't want to cause confusion here, I'm going to erase that. I was just trying to show you that, there's a division sign, so that's what I need to start with. So I am going to ignore everything else for the moment and pull out the 2/9 divided by 4/3. I have to get that simplified first. So going back to division rules for fractions. Step 1 is to flip the second fraction and turn the division to multiplication. So I have 2/9 times 3/4. This is also a good way to review whether you're remembering the different fraction rules, right? Like pausing for a second and saying, division, what rules do I follow, right? Identifying it, and then you can watch the video, or trying it and then watch the video. Anytime you can quiz yourself and test your knowledge, that's how you're going to figure out what you need to review, what you understand, right? And in order to do especially exams that have a mix of content, you have to make sure that when you see a problem, your brain knows what it needs to do. Okay, so I've done my reducing now, or no, I haven't. I did my flipping and multiplication. Now I need to do my cross canceling. So I do see that 9 and 3 have a common factor. So 3 goes into 3 one time, 3 goes into 9 3 times, 2 goes into 2 one time, 2 goes into 4 twice. Now I multiply across, so I get 1/6. So 1/6 replaces these two fractions. So I need to rewrite. So I have 7/15. This is positive, so it's a plus 1/6. So if that had been a negative 1/6, I would have 7/15 minus 1/6. So the sign in front of a number is the operation for that number, okay? And then we have minus 4/5. Okay, let's look at the 15, the 6, and the 5. And first of all, it's only addition and subtraction. So I finished my multiplication and division, right? So I'm going back to order of operations. And now I just have addition and subtraction. So that means I need to go left to right. But like previously, I'm going to go ahead and find common denominators for all three. You could start with the 15 and the 6 if you wanted. Do your combining and then do the next one. But again, I'm just going to go ahead and find something that works for all three of them. Okay, so I have 15 as my largest denominator. 15 times 1 is 15. 15 times 2 is 30. Look at that. 6 and 5 both go into 30. So that is my common denominator. All right, so left to right, I'm going to start with those two, okay? So I'll just write it down here with a little bit more room. Plus 1/6. So I need to multiply the 15 by 2 to get 30, top and bottom by the same thing, times 5 to get 30/5. So I get 14/30 plus 5/30, and that, over 30, and that gives me 19/30. Okay, so like the last time, right, I simplified the first two. Now I need to rewrite my original problem, but replacing the 7/15 plus 1/6 with what I just got, okay? So now it's 19/30. Well, I already know that I'm going to use 30, right, for my denominator, so I'm going to go ahead, just to save space, and get this converted, right? 5 times 6 gives me 30, so I multiply the bottom by 6, multiply the top by 6. So I get minus, right, -4 times 6 is negative 24. Oh, haha. I'm going to show you something. So notice that negative, right? That looks like it's become a double negative, but I actually already took the negative into account by putting that minus sign. Okay, so I need to just leave that as 24. So you can use that as an example. Well, negative 4 times positive 6 is a negative. So I'm going to place that. That's my subtraction, which is the same as a negative number, or adding a negative. And that becomes 30 equals, draw my line, put my denominator, and now I'm ready to subtract. So 19 minus 24 gives me negative 5. We need to pause. Is that fully reduced? No. 5 goes into both the top and the bottom. So I'm going to divide by 5, and I get negative 1 over 6. And that is my final answer. Okay, so as I said before, go ahead and pause the video, and I want you to go ahead and work through the next set of problems, and then I'll go ahead and do it for you. In fact, I am going to create another problem. So this is the third 4.6 video, and we're going to be simplifying with order of operations, and this is going to include everything we've done before, plus our parentheses and our exponents.